So from here, from this center, again we'll go back to drawing and we'll decide. Let me check how much distance it is projected. Where is our face? Okay, where is our origin? And from there, how much it is projected? Now tell me. Based on your answer, I'm going to do it now.
50, sir. 50.
Is that right? I need one more answer. Guys, you can answer in the chat. How many of you say yes for 50? Say yes, yes, yes in chat. Just let me see your answers. 50 is correct? Guys, I'm waiting for your answers. One. Come on, come on, come on. Only one. How many of you are in the class? 13, yeah. Come on. Okay, so far I can see only 3 answers. 1, 2, 3. Under 10 members, please. Respond, respond. So that I can understand you people are getting it or not. That's the only intention behind this. Only 3 answers I got. Any other answers? I got some more.
So, sir?
Yeah.
So which dimension are you asking?
I'm asking about this dimension. This I have created this, right? What I have created?
Yes.
Now I
The
have
outer
created the cylindrical portion, right?
Yes, sir.
Cylindrical portion, only the front face I have created. Now I'm going to use pad option, okay, to create this. So I'm going to project it. How much length I need to project?
Yes, sir. 50, sir.
Okay, good. That is what I just wanted to see how many of you understand. That it will be little difficult to understand initially how to study the drawing. Okay, guys, other guys, are you okay with that? Are you okay with the 50? You around 13 guys are there. Only 3 or 4 answers I've got. Okay, remaining people, are you okay with that? Are you getting it? Very simple logic. Okay. Guys, you need to respond here. Okay. Again, I'm going to project it now. Okay. So which direction we need to project now?
Reverse directions.
You said 50. Okay. So it should be reverse direction. Say reverse direction. You can see here. Okay. Reverse direction. If it is exactly in the middle, you can say mirrored extent. Then mirrored extent will see. You can see this option, mirrored extent. Okay. If you want to use this, simply click on this and this will be mirrored. Okay. Now we don't need mirror because our face is starting from here and it is projected towards back. Okay. 50 mm. Okay, guys. So we are done with this portion. Okay. Now let's go back to drawing. Let me save it. When you are working on Catia, always it's better to save it. If you lose it, again you are going to, you'll be in trouble. You have to create it right from beginning. Okay, now I'm done with this pad, bottom pad. I'm done with this cylinder. Okay. And now I need to finish these 3 walls or these 3 ribs. Okay. So how to do that? Okay. So how about this portion? If you look from front view, can you finish this from front view? From which view you can finish this? Or top view, do you need to model it? Where you need to take the sketch? Look at this. Look at this portion. What I'm showing. So this is mirrored. Okay. This side and as well as this side. Okay. So which face we need to take now? Which face we need to consider? Which plane? Can you let me know? I want to create this rib. So which is the face I need to consider now? What is your opinion? Guys, any answer? I want to do this portion. This rib I need to complete. Any answer? Any answer? You can just reply in the chat. Any answer? Think and tell me. Guys, thinking?
Left view, sir.
Left view?
Yes, sir.
Okay. Any other answers? Okay, let's see left view. One answer is left view. Okay. So from left view, this is front view. Okay. And this is left view. Okay. With left view, which rib you are talking about? The front one, or the side one?
Front one, sir.
Front one.
Yes, sir.
Talking about this.
Yes, sir. Yes.
From left view, we can finish this. You mean to say, right?
Yes, sir.
Okay. And how about this rear one?
By front view, sir, we can do.
Front view?
Yes, sir.
Okay. All agree? Guys, all of you agree? Just say yes. Just say type yes if you agree. Type no if you do not agree with him. Now, who answered it? Sorry,
Sir, Balaji Singh, sir.
Balaji.
Yes, sir.
Yeah, thanks for answering.
Okay. Yes.
Okay, guys, do you agree with Balaji, your friend? He said the front rib can be finished, completed by side view. Okay, and the rear rib can be completed by selecting. That can be done on what is that plane? YZ plane itself, YZ plane, ZY plane, what we selected initially, same plane. You agree, guys? Because later on you have to model it, man. So that's the reason I'm questioning. Okay, you need to understand. Okay, let us see. So you said to complete the rear portion, we can take front view. Let's try with front view. Okay. So, and at what? At what is the thickness? It is 14 mm, right? And so let's consider the option which we are going to use here to create this is rib. Okay. Not rib. stiffener. Here it is known as stiffener. In another software, it is rip. Stiffener or rip. It is provided to strengthen the part. Okay. So we are going to use this stiffener. Okay. Okay. Let's consider that, and let's see where it is placed. 18 mm from this face, isn't it? From the front face, it is 18 mm rearwards. So this is my front face, and from 18 mm it is starting. Okay, 18 mm, and what is the thickness? 14 mm. So I need to take a plane. I need to have a plane at the distance of 18 plus 7. So we have to consider it at the mid of this figure. Okay. So if you are using this stiffener option, then always consider that at the mid of this, and then it takes thickness both sides. Okay, please remember that. So that's the reason we need to consider neutral fiber. Okay, this is neutral fiber is at 7 mm. Okay, 7 mm, that is from this face 18 plus 7. So let's consider a plane. I'm going to offset a plane from here. How much offset? 18 plus 7. Okay, the preview. Where do we need to have this? Here,
Reverse directions.
reverse direction. Okay, good. Done. Now, this is our neutral fiber. Okay, neutral plane where we are going to create these ribs. Simply select this. What is the orientation? I'm okay with that. Okay, and now I need something for my reference. So, what is the option to project this? Project 3D elements. Okay, please remember this. Project 3D elements. I'm going to project it. Okay, say okay. And also I need something here which I can refer. Now they are in yellow color. Yellow color in the sense, again, this line is, the circle is linked with this 3D element. Okay, so I don't want that. So isolate it, and let's fix it. I'm fixing it just to save my time. Okay, done. Now again, isolate, isolate, and just fix it. Remember these options. Okay, you don't need to use fix always. You need to just constrain it. Okay, now I need to create the ribs. How to create the ribs? So, so these points are not constrained yet. Let us see, this point is constrained. This point is important for us. This point is not constrained. Okay, so I have constrained this starting from this edge. So also this point I need to constrain. Okay, the length is constrained now. So let us see the difference here. If it is exactly coinciding with this, then that will be a filled circle. Can you see the difference? If you keep your cursor here, then it is a circle which is not filled. Now if you exactly coincide with this, then you can see a filled circle. Am I right, guys? Can you see that? If it is exactly coinciding with the point, then that will be a filled circle. Then if it is not coinciding, then it's a empty circle. You can see a circle is formed here. Small circle. Can you see that? Now this is okay. And I need a solid one, so I'm going to switch this off. Construction element, I'm switching off. I switched it off. So now this line is solid line. Now I'm going to create a line which is tangential to this circle. Now this line is tangential to this circle. And I want this also a solid line. Okay. And now I need one more line which is required on the right side. Select this. Okay. What is my profile? Trimming it. What is the option I'm using? This is the click on this, on the line, and again click on this, click on the line, and just click on this. And make sure this line is also tangential to this circle. Let us check. Now it is tangential. Okay. Okay. So now my profile is done, but let's check how is my profile. So it is open. Okay. It is open. For stiffener, open is okay. Okay, we can use it for stiffener especially. Open sketch is okay for us. Okay, guys, any doubt in creating this till now? Any doubt how we created this? Okay, let's come out. Okay, now this is our stiffener. Let's use the option here. Select the profile. Okay, and now you can see here neutral fiber is on. Okay, you can give one side this also, like the thickness also, by creating a plane exactly 18 mm from here, but we have selected neutral fiber. That's the reason we need to give 7 mm here. Total thickness is 14 mm. 7 mm. What is the thickness actually? Is it 7 or more than 7? It's 14 mm. Okay. Okay, we have to give 14 mm. It will take 7 seconds. Okay, 14 mm here, and it takes 7 both sides. So you can see now the exact face is matched here. Okay, the rib is completed. Okay, now what is left over? Let me save it. Guys, all clear till now? Okay, so this rib is completed. Let us see what drawing is saying. The back one, okay, 14 mm. Is it 14 mm? You want to check? Simply go here and just check with this face to face. You can select, and it will show you what is that 14 mm. Okay. Now what is left over? Only is the front one. So as per Balaji, we can do it from side. Good Balaji, we can do it. Okay, from side, and that from front. Now let us see what is the orientation it is taking. Look at this. Vertical is here, horizontal is here, but I want vertical. Let's swap it. Okay, say swap, Then see here, now vertical is here, horizontal is here. Is that visible? See now, vertical is here, horizontal is here. Initially it was like this. It was vertical is here, horizontal was here. Now I swapped it, okay, and I said okay. This is my normal view, okay. My view is like this or like this. If you want to have side view, just click on this. It will give you exact view, okay. Now coming to the projection one, okay. Which one we need to project? For my reference, I projected this one, as well as I need to project this one. Right. Let me isolate and delete whatever things are not required. Okay. For me, all these things are not required. Say auto search, not auto feature. Okay. Left click on that and say auto search. The whole profile will get selected and deleted, and just simply delete this one. Now we have only one line, which is for our reference, and simply fix it or constrain it. Okay, say coincidence. Okay, and now this point also should be constrained. I constrain the point also. Okay, coming to the bottom one, isolate this and again fix it or constrain it, and make sure even the last point is also constrained. Okay, because we are going to make use of the last point. Okay. Okay, so this I want a construction element, and this is also for me a construction element. Okay. Now switch it off, construction element, and I'm going to create a profile here. A profile which matches with the, so it should be till where? Till the bottom of this cylinder. Okay. Bottom of this cylinder is this point. Now this point to this point, I'm going to create one profile. This is my profile. This is already constrained, because as we have already constrained this point and this point, so this profile is already constrained. Okay, let us see. Check our sketch analysis. This is simply online and it is open, and open is okay for us because for stiffener it is okay. So I'm coming out, simply click on the stiffener, click on this, say okay. Okay, so let us see what is the thickness of this. Thickness is same, okay, 14 mm. So if you see, this thickness is also 14 mm, and exactly it is matching now. Okay. Okay. So this is our model as per the drawing. So to make it clear, let me hide this planes, and also if you want, you can hide this axis system. Okay. And if you want to rename, you can rename it. Right now, let me just save it. Okay. And now I want ISO. What view they are showing? They are showing like this. ISO view. So let us create an ISO view. What is our ISO view? this with edges. Okay, what is ISO view for us? This is our ISO view. Okay, so this is our ISO view. See guys, sometimes ISO view will be different. In those cases, you can edit our ISO view also. See, you can go here and which view you want to edit. For example, ISO view, say properties. You can see here, select the ISO view, and now you can change it. Okay, say apply, and it will show different view here. Okay, this will be your ISO view. Okay, so there are requirements to different ISO views. If you don't want this view, then again click here. Okay, or which way you want to have this. So that ISO view you have to click. Okay, you want to have this kind of ISO view, then this will give you this kind of ISO view. Okay, you want this. So this is what our drawing is showing. So let us see. Okay, say apply, say okay. Okay, our drawing is showing the front view is this one. So now let us see what is the ISO view is showing. This is wrong ISO view. Okay, so let's correct it. Say ISO view properties, and then select ISO view here, and then this side. Okay, apply. Good. So this is what we want. So, okay, apply. Okay, let's save it. Now go back to drawing. So this is our reference one. Let's keep it here. And now let's take an ISO. Here is my view. Select one plane. Okay. So you can see here you have something here for adjusting. So ISO view is this, and if you want to rotate it or if you want to change it any direction, you can do that. Okay. So as of now, this is our ISO. Let's keep it as it is. Okay. As we increase the size of this, maybe that's the reason it is. Let's increase the size of this so that we can see. It's too much here. Let's make it 5:1. Five is to 1. Okay, guys, got it? So you can see match with the given one and see how it is showing. Okay, only thing is the axis is not created in our say center line. Okay, just activate this view, just double click on this and then right click on this, go to properties and then say hidden lines if you want, but and then center line. Okay, say apply. Don't need hidden lines, huh? Everything it is going to show you, even the rear side parts also it's going to show. Only axis, even the axis is not shown here. In that case, manually we have to create it. Okay, manually create. Say here, so this will be your axis. Okay, and one more, if it is parallel lines, between the parallel lines, you can just create like this. This is our view. And what will be the value addition for this? In this drawing, they have given only basic details of this. Okay, they have not shown any of the details. These are just basic things. Okay, no like two holes are missing here. Let's finish the two holes also. You know how to create this, huh? So to create this, what is the view I need to use? These holes. Any answer? From which view we can create this? Which plane?
Top view, sir.
Sorry.
Top view.
Very good. Okay. Simply can put this top view. Okay. Hide your axis system. This is the top view. Okay. And on this face. Okay. We need to create a plane here. But let's just to save our time. I'm just see again here. It's vertical and horizontal. And just say swap. And now vertical is here. So say reverse vertical. Okay. And now simply you can create this. What is the dimensions? What are the dimensions for this? Dia of this. See, only for one hole they have given the details. Okay. Two holes are available. Diameter 12. Okay. The diameter of both the holes are 12 only. Okay. And location of the hole is given to only one. That means both are mirrored. So if we have to consider only these dimensions, okay, and then create it. Okay. From here it is 24. From this edge, left edge, it is 20 mm. Okay. Dia is 12 mm. Okay. Simply dia is 12 mm. It is 12. And from here it is 24 mm. So my reference is, for my reference, I'm just creating this. Say okay. Okay. And then say isolate. And just fix it. Okay. And then should not be fixed, guys. Okay. I'm just taking my time. It is 24 from here. Again from this edge, so you also can directly do it. But again, as I said, part will not go. Okay, that's the problem. That's the reason. Instead of doing this, have some patience and do this. Not patience, you have to do this way only. Just say isolate. Just, fix it. Okay. Even if you fix it, it's not going to move. Okay. And now construct. Okay. Now either so we need same here. Okay. So what we can do, we can simply say mirror extend, click on this and click on this. Okay. You have another hole here. Got it, guys? I just use mirror extend here. Okay. The same I created here. Mirror extend. Okay. Okay. We don't need 50 mm. Stay up to next. Okay. And we are done. Save the part. Done. Okay. Now what drawing is asking? It is asking for update. Okay. Can you see it? This is the symbol of update. Okay. So it is asking for update. Okay. Just right click and say update. Then these holes also you can see here. They also get updated here. Okay. Okay, so these are the drawings. Okay. Now let's make it 1:1. Okay. And one more thing, what we can see here, what will be the value addition? Being a mechanical engineer, okay. So what is first priority for us? If you are designing something, if you are designing a part, or if you are designing anything, then what should be considered first? So, as we discussed in our initial classes, that when a seat is designed, then definitely the things which we consider depends on the points which are H point, okay, reference point, and E point, which is I point. So these are the initial points, knee point and heel point. Okay, all these points are considered. Why those points are considered? Because we need to make sure that the vehicle design or the seat design is safe. Okay, safety is important for occupants. So it should be designed considering the safety first. Okay, so why E point is considered? So that we can, while designing, we can avoid all the obstacles, and we can design it at a height, or at a distance where driver can access all the controls, so that he can have safety. Okay, he can control the car, he can access everything. Okay, and he can have safety. So at the same time, always when you design anything, you need to keep safety in mind. Okay, safety of the person who is going to handle this. Okay, that also we need to take care. Okay, so if there are sharp edges, okay, then definitely it's going to hurt. So to avoid the sharp edges, what are we doing? So what you did in lab, actually, machining lab, what you used? So you did some machining in the lab.
Fillet we have to provide, sir.
Good. So we have to provide the fillet. Okay, we also either fillet we have to provide, or another thing is chamfer. We have to create chamfer. Can you see it? Chamfer or fillet. Okay, so that's very important. That will be our final thing. Okay, but based on the input, so how much fillet we have to give, that is also given by, sometimes it is given by uh, customer. Okay, so based on the dimension, we have to give chamfering and filleting. Okay, so let's have a look at here. Okay, you can give fillet like this because this is a sharp edge. Okay, you can select inner edge also, and the rear side edge also, the side edge also. So now you can see what how it looks. Okay, and all the sharp edges you can avoid. So before giving here, see, first we have to give the, to make sure that it is flowing freely. So you have to give these edges, which this edge is going to create a path for the vertical edges. Horizontal edge, if you finish, okay, and then you fill it to the vertical edges. This edge, okay, this edge. Okay, so this will completely change the shape of the view of this part. Okay, and what are the other advantages of filleting? This, not face. Okay, this and this. Okay, it increases the durability of the part. Okay, filleting. How?
Stress concentration is reduced, sir.
Exactly. So it distributes the stress, okay, over a broader area, we can say. So this is smoothly, stress will be smoothly distributed over a broader area. So in that way, if the area is very sharp, it's very easy to fail actually in that area. Okay, if the part we have sharp edges here, so stress is not going to be smoothly distributed. That's the reason that's going to there are chances of failure. So that's the reason. Maybe here in this drawing it is not shown, but this is how we have to give. Okay, and chamfer is useful for the holes and all. Okay, now for example, see here holes are there. So why chamfer is given? Even chamfer is given for removing the sharp edges. Okay, and deburring also. Okay, deburring also it is used, and also if another fasteners are coming and sitting here, then that will make this chamfer easy for the assembling of the that insertion for the insertion of this that fasteners. Okay, so that also is very easy for if you use chamfering. Okay, and we have to use it because initially we are creating only small models and simple models where all the details are not available. Okay, so later on we will learn all the details like other details, kind of how to create the drawing and how to control the surface toughness symbols. Okay, I'll show you how surface toughness symbols, how to control the surface, and how GD&T is given. Okay. So what is GD&T? We can see it's a vast subject. Again, it's a big subject, and we can see how GD&T is given and what is GD&T, geometrical tolerancing and dimensioning. Huh? How it is, it should be controlled. If a hole is given, then how much is the tolerance given? Okay, allowed tolerance. What is the allowed tolerance? All those things we can see in the GD&T. Okay, so after finishing this, if you come back here, then this will ask again update because you change something in the model. So you can see here now. Okay, you can see chamfering what we have given. It is reflecting here, and you can see all these fillets what we have given. Okay, you can see all the fillets here. Okay, apart from that, now after finishing the model, what you have to do, you have to create the drawing. So how to create the drawing? So you need to see what are the important portions. You have already decided. So which is the important view for us? So front view is the important view. Which view is important? This ZY plane. Yeah, YZ plane is important for us. That is our front view. We consider that as front view. So that's the reason we create the front view. Okay. So this is size of the sheet is very big. Huh? You don't need such a big size sheet. Okay. So how to change the sheet? Just go to properties here and see here. You can select the size of the sheet. Okay. Say A0 is very big. Okay. Let's say A3. Say apply. Say okay. Now you can grab this, just drag it, just drag it here. Okay. You also can insert. How to get into background here? Edit, sheet background, title block. You can insert the title block. Can you see the option here? So where are we? I'm again coming out. Working hours. Can you see working views here? This is our working views. Okay. These are our working views. Okay. Edit, sheet background. When you go to background here, then simply say frame and title block. Okay. Click on this and say create. Okay. Say apply. Say okay. Okay. Now come out. So there are few things which you have to fill in background also, but usually it is okay if you fill it in working view only. Okay, all these details, if you want to edit this date itself, then you can edit it here. Okay, in background. Now come out here, working views. In working views, you cannot edit anything in working views. Okay, if you want to edit all these details, then go to edit, sheet background, and then edit all these things. Okay. Okay. So this is our front view. What else is required? This is our ISO view. Let's make it a little small. ISO view. So now let me consider side view where I can get few details. Okay. And also let's consider the top view. This is my top view. So as for this drawing, if you see, so actually in this drawing, all the dimensions are shown in ISO view itself. Okay. So guys, your homework is, you have this drawing, right? Have you taken this grab of this? Please take grab of this, or I'll post it in our group also. You take a grab of this and create this drawing. Okay, so all the dimensions are, once you finish this model, okay, try to finish it and then create this. All the dimensions are shown in ISO view itself. So you see what all dimensions we can see, we can show in front view. Okay, as per this is our front view. In front view, you can show the dia of this outer cylinder, dia of this whole of this cylinder. Okay, and this is front view again. Okay, and thickness of this pad, front width of this part. Okay, all these things can be shown here. Okay, so what we can show here, dimensions. How to show the dimensions? Where are the dimensions? Here is the tool. Okay, this is the tool. So I can show this. I can show in front view. This 14 mm we can show. Okay, this is incorrect. It's not 14 mm. You have to select from this edge to this edge. 16 mm. Okay, this is 16 mm. Okay, this is 110. This is 16 mm. What are the dimensions we can show? This dimension we can show. See, this can be shown. Okay, and This dia can be shown. 44. Inner dia can be shown. Okay. 26. Can you see it here? 44. In front view, you can show it. 26. We can show it here. This thickness, we can show it here. This dimension. Okay. Again, this is 48. Okay. So that dimension also it can be shown here from this face to this face. It is 48. Got it? And this is 16 mm. This side they are showing. Okay, let us show it here. This is 48 mm. You can see here 48 mm. This is 110 mm. And this one inside view. Inside view, you can see this. This is the 62 mm. From here to here, 62 mm. Okay. This we can show in side view. Okay. And what all details we can show in the top view? This 50 mm we can show top view. Okay. From here to here it is 50 mm. Okay. And details about the circle. Again, go here and say center lines. Okay. We have axis here for the both circles. Okay. What is the distance from here? From this edge, it is 20 mm. Okay. So where it is selecting, see why we are getting 2.20.3x. There is some deviation. We need to check where it is selecting. See, this is selecting this edge. We have to select the final edge. Okay, that's because of the fillet what we have given. Okay, so if we delete this fillet, then you can get this dimension. And what is the dimension from here to the rear edge? Okay, no, not this. From here. From this view, from this center to this. How much is that? 24. Okay. This is 24. This is 50. Okay. And 16 mm. 48. Okay. And you have to show that two holes pi 12. Okay. This you have given here. Okay. We are given a chamfer here. That's why we can see two the holes here. Okay. So if you take directly, you can go for text. So if you want manually, if you want to write something, there is a option T or this. Okay, text with leader. You can directly place on this and say dia 12. Okay, dia, to click on dia, you have to click here. Okay, dia 12. Two holes, dia 12. Just they said first two holes and then dia 12. Okay. Say dia. Can you see here? We have a toolbar here where you can find all the symbols. Okay, all the symbols you can find here. So you can say Jaya. Okay, and 12. Okay, that's how we have to write it. Okay, any dimension is missing? Yes. What is missing? This 18 mm is missing. So from this face to this edge, it is 18 mm. From this face to this, it is 18 mm. Okay, and here we want center line. Now we got center line here. Okay, and from this axis center to this edge, it is 64. Am I right? This is 64. Okay, so they showed everything in ISO view, but if you properly create a drawing, then this is how you have to show in front view. What all things are visible in front view, you have to show in front view. Okay, and in top view or side view also you can show this 50 mm. Okay, in side view, what all dimensions you can show, those dimensions you can show in side view. Okay, these rib dimensions also you can show in side view. Where is the side view? Here is the side view, rib dimension. Okay, it is 14 mm. Okay, is anything missing? 110/62 is shown. 62 is shown here. Okay, see, if you move it, it is difficult to move this. Okay, just hold the shift and then move it. It will smoothly move. Okay, hold shift and then move it. Okay, so 1 2 3 4 5 1, 2. Okay, just okay, guys. Any questions in this? So this is the input. Okay, this is the input drawing. Usually you won't receive input drawing like this. There will be different inputs. Sometimes you will receive like this, and sometimes you receive like this, okay. Sometimes you may receive like this direct drawing, and then you have to, based on these drawings views, you have to create the 3D. Okay, or if you receive like this, then you have to create a 3D as well as a drawing. Okay, or sometimes you may receive only ready-made drawing, ready-made 3D, and then you have to create a drawing out of it. Okay, sometimes it is reverse. You may receive only a drawing and they may ask you to do this, or they may ask you to just delete these holes, we don't want holes, and update the drawing. Okay, you have to, or else they may ask you to reduce the thickness of this. We don't want 16 mm, we want only 15 mm. Just reduce it and do it. Okay, update the drawing. So that's the kind of designing modifications, or 2D to 3D or 3D to 2D, or sometimes you will receive a dumb model. Dumb model in the sense, you will receive a model like this. Okay, but that is without history. You have a history here. Okay, this is history. And you can directly get into this, double click and modify it. It's very easy to modify. Okay, but if you don't have this completely, if this is a dumb model, then how you are going to modify it? You cannot modify it. So you have to, with this as reference, you have to model one more part, this as reference. How to do that? That also I'll show you. Okay, so that is another part. Okay, guys. So Any questions on this? Is everything clear in creating drawing or creating?
Sir,
Yeah, yes, please.
so in the starting of the designing, sir, you selected the symmetry and coincide option, right?
Sorry, can you repeat? It's not
The
audible.
the symmetry and coincide option, sir.
Symmetry.
Well, coincide, sir. At
Yeah,
the
yeah,
start of the design, sir. Where can we get that option, sir?
yeah. I'll show you. Well, you're talking about the sketcher, right?
Yes, sir, yes.
Sketcher workbench. Okay. Let's get into sketcher. Mostly we would have used it in here. Okay, you mean to say here? Here we used, say for example, if we create a whole circle here, okay, go constraint, okay, constraint. Click on this, select the center, and then select the center of this or where you want to coincide it, and then right click. Okay, after getting this dimension, you can right click and say coincidence.
Okay, sir.
Okay, and what was the other thing you wanted to?
Symmetry, sir. Symmetry.
Symmetry. Huh? Here you can see allow symmetry. Okay, but it depends on this cannot be symmetry. So if you want to see symmetry, so for example, that case is different. That means you have something like this. Two lines we have. One line is somewhere here. Okay, and one more thing, guys. When you are drawing a line, have you observed at one position at one angle this is blue in color? Okay, it's turning blue. That means this perfectly vertical. Okay, if it is at an angle, then it is white in color. When it is exactly vertical, then it is, see, you can see V. That means this line is vertical. At the same time, if you are drawing the line a horizontal line, then again this comes into picture. See, if you are drawing a horizontal line, it automatically takes the tangency with that. Okay, you need to be very careful. So again, see, if it is at an angle, then it won't be blue. If it is exactly horizontal, it will be blue. Okay. Okay. Now let us see how to use these lines. Okay. I've created one line here and one more line here, and I want to make sure that these are symmetrical to this axis. Okay. So first select these two, and finally select the axis where to which you want to make them symmetrical. Now you can see symmetrical here. Okay, say symmetrical. Then you can see this symbol. This is the symmetrical symbol. This line is vertical as well as symmetrical. Got it?
Yes, sir. Thank you.
Okay. I'm deleting this. I'm deleting this. Okay, and let's check our sketch. Close, closed, all good. Okay, so we can come out. Okay, any other questions? Guys, if no questions, then please try to model this. Okay, I'll send you this image. Okay, try to model this and create the drawing also. Okay, hope you are clear how to create the drawing. Okay, mechanical design, drafting. So here if you go, you can get into drafting. That is nothing but drawing. Okay, and if you don't know how to create all this in the background thing, don't create that. I'll show you again. Okay, no issues with that, but at least you try to create these views, okay? Front view, side view, top view, and try to give all these dimensions, okay? That is your homework. Please finish it because you have to start modeling now. We have already completed almost 5 models, okay? 4 to 5 models we have completed. So by now you can understand what all the options are available. You do it slowly. If you have any question, you ask me, okay? And then only you can learn. Unless you practice, it is difficult to learn. Huh? That's the reason. Start doing it and let me know your questions, okay? So is that okay? No questions?
In order to draw the ribs, which reference plane have you taken?
Sorry?
In order to draw the ribs, which reference plane have you taken?
Which
Reference plane.
reference plane you have to take?
Yeah.
See, in order to do it, it depends, right? We cannot decide on one reference plane. So for this drawing, based on the orientation of this part, so we decided to see. If you see the drawing, so the ribs we have considered ZX plane, right? So first these for
ZY plane.
yeah. So this is the ZX plane we have considered. Okay.
Okay.
ZX plane, you can see where is that? Axis is let me just open this. So on this plane we have taken, okay, Z and Y. ZY.
Not that one, sir.
ZY
For
plane
the
we have considered.
sketch 3.
Which rib you are talking about? The rare one or
Yeah,
the
that one. That one. Rare one.
rare one, right? So rare
Yeah.
one, see which is the parallel, okay?
Mhm.
This face is the parallel for this. And
Okay.
how to use this option, if you have idea on that, then you can easily decide, okay? So if you see how the rib option is working, the stiffener option. So the stiffener option is, if you click on this, okay, you can see the stiffener option is working like it is taking thickness either from the neutral fiber, okay, or if you remove this neutral fiber from mid of this neutral fiber, it is the thickness is getting distributed towards outwards, from inward to outward. That is 7 mm to left side, 7 mm to right side. Okay. If you
Okay.
remove this, you don't need to consider the neutral fiber. You directly can take a face, a plane, exactly at this face. You have to see the dimension, how we calculated. You saw, right? How we decided the dimensions, how we decided the calculated dimensions, and how we created the planes to make sure the all the dimensions we can achieve. That's very important. We have to do some analysis, do some study, and then we have to create some planes so that we can finally, the final output is drawing. You cannot get the dimensions unless you do it perfectly. So if you even see in our drawing, because maybe this is not selected, this is selecting stuff, is missing something. That's the reason. See,
No, we haven't.
saying 20.36, but this is actually 20. Okay, even this is not acceptable. If you're working in a project, the customer will not accept 20.3. Why you are getting 20.3? Where you did mistake? Okay, that we have to find out. And there are so many ways to just, you can go here and see how much, what is the decimal points maintained here. See, if you see here, tolerances, okay, dimension lines, value, precision. What is the precision maintained? 0.01. Okay, even you can change this here. If you say 1, you can change it. It will become 20, but customer is going to check here. So at this precision 0.02, 0.01, you should not get this value. Okay, at this precision you have to get 20. That is the condition. Okay, so that's why we need to be very careful while calculating our dimensions, where we are creating the planes. Okay, where we are what option we are working on. If it is a stiffener, how the thickness is getting distributed, and finally what is the dimension, are we going to achieve the same dimension or not. So these things are very, very important. Okay, you need to be very careful while working on that. Okay,
Okay.
so you just when you start practicing, you will understand how these things are getting distributed, even the thickness, how the thickness it is taking. Okay, so as of now we have considered ZY plane. Okay, and that plane also we have considered or else I'll do one thing. I'll ask Joy to share this model with you, and you people can practice it. Or anyhow, you are going to get this link. Okay, with the help of the video, it will be easy for you to understand and do that model. Okay, even front rib, how the side view we have considered. Okay, either this side, left side view, or right side. That's fine. You can consider either of the sides, and you can create it. Okay. Okay. So is that clear? How we created this rib?
Yes, sir.
Okay. So a video will help you. Okay. That link I'll ask Joy to share that link also. That will help you. Okay. You can
Sure,
just
sir.
go to that and practice that. Okay, guys. Thank you so much then. Okay, please practice this part, and please come with your doubts, questions, queries, and day after tomorrow we'll see. Um, Based on please, one guy, it's good to share your drawings, man. So let me see how you people are getting it, or how you people are understanding it. I want to now understand what I'm teaching you is okay, or do I need to go slowly, a little bit slow, or am I running fast? So I need to understand, and you people please start working on that, and then we can have an understanding, and then we can go slowly if you want. Okay, so please do that, because anyhow you have to model few more, start modeling few parts,